there, and welcome to a little bit of instruction about general skill number 8, and that's all about the unit circle and periodic functions. You'll find this in section 5.4 of our Blitzer text, and we're going to focus today on introducing you to the unit circle. All right, so last time we talked a little bit about trig functions of any angle. And remember, we created these reference right triangles by using the terminal side of some angle theta and then dropping a perpendicular down from any point on that side. And so when we did that, we formed this right triangle, and then we used our SOHCAHTOA ratios and came up with some great tools to define the trig functions for any angle on the unit circle. And we define those to be sine of theta was y, the opposite over r, which was the hypotenuse. Cosine of theta was x, which was the adjacent side, over r, the hypotenuse. Tangent of theta is y over x, also known as opposite over adjacent. And then the three reciprocal functions. Cosecant of theta is the reciprocal of sine of theta, which is r over y. And secant of theta is the reciprocal of cosine of theta, which is r over x. And cotangent of theta is the reciprocal of the tangent of theta, which is x over y. Now remember that we used r to represent our hypotenuse of that reference right triangle, but we use the letter r because we can think of r as the radius of a circle. And so if it's a radius, it's a distance, and it's always positive. All right, so now we're going to take this information and we're going to translate it into what we know to be the unit circle. So in order to do that, we need to backtrack a second and remember that the equation of a circle is x minus h squared plus y minus k squared, and that is equal to the radius squared. Now the center of the circle is represented by the coordinate hk when we are using this formula. And remember that r is going to represent our radius. So then let's focus on this particular circle. And in this particular circle, it's in this form, but notice there's no h and there's no k. And so that means that this circle has a center at the point 0, 0 and a radius of 1 unit. Now this particular circle is known as our unit circle because its radius is 1 unit. Now, if I'm looking at this drawing or this diagram again, and we are considering this to be our unit circle, and so we're going to have our radius here as 1 unit, we can take those definitions that we came up with before and then replace all those r's with 1. So this r will become a 1, this r will become a 1, this r will become a 1, and this r will become a 1. Okay, so let's do that. And so this shows how those definitions are slightly modified when we are restricting our view, our lens, to any points that are on just the unit circle. Okay, so let's see how we can use that. One thing that we can do if we know that a point is on the unit circle is if we are given any coordinate, the x coordinate or the y coordinate, we can find the missing coordinate. So for example, let's say that we're given a point that's located in quadrant 2 of the unit circle, and it has a y coordinate of 3/7. And we are asked to find the x coordinate. Okay, so we would remember that the equation of the unit circle is x squared plus y squared is equal to 1. And then we would take what we know to find what we don't. We would take the y value, which we know to be 3/7, and we would put it in this formula for y. And then the only variable that's left is x, and so we can go ahead and solve for x. We would start that by squaring 3/7, which means squaring the numerator of 3 and getting 9, squaring the denominator of 7 and getting 49, and then isolating the x squared by shifting that 9/49 to the other side. Then we would want to combine those constants, the 1 and the -9/49. To do that, we're going to need a common denominator. So we would turn this 1 into 49/49, and then we would subtract the 9/49. And we would get a result of 40/49. Now, to isolate the x, we would need to take the square root of both sides. And remember that when we do that, we need to find all possibilities that satisfy that equation. So x would actually equal plus or minus the square root of 40/49. And we would want to clean that up a little bit. We would want to think of that fraction under the radical as a radical on both the numerator and the denominator, and think of them separately. So that would become plus or minus the square root of 40 over the square root of 49. And we know what the square root of 49 is. And we'd also simplify the square root of 40 to be 2 square root of 10. So our answer for x would be plus or minus 2 square root of 10 divided by 7. And then we would want to actually answer this question correctly based on what we know about this point. We know this point is in quadrant 2, so we know x must be negative. And so of these two options, we would pick the negative option, which is x is equal to -2 square root of 10 divided by 7. And that would be our missing coordinate. Now, another thing that we can do using our unit circle is select a point that's on the unit circle and find the 6 trig functions for some real number t that represents the angle that would be created if we were to draw a line from the origin through that point. Okay, so sometimes it's helpful to visualize where that point is. And we know that this point, -15/17 divided by -8/17, we know that that's going to be in that third quadrant. So now we're going to go ahead and remember those definitions that we just came up with for those trig functions. All right, and we know those to be these. Sine of t is equal to y, cosine of t is equal to x, tangent of t is equal to y over x, and then our reciprocal functions, cosecant of t is 1 over y, secant of t is 1 over x, and cotangent of t is x over y. Okay, and so now we're going to utilize what we know about our point. From this point, we know that x is equal to -15 divided by 17, and we also know that y is equal to -8/17. So we're going to replace our x's and y's with those values, and then we will simplify. So let's go ahead and replace everything. Replace all those x's with -15/17. It's always a good idea to replace your x's anyway. That was a little bit of math humor. And then we're going to replace your y with, or all of the y's with -8/17. So let's do that. Okay, here we go. And now we've got a little bit of simplification to do. Anywhere we have a complex fraction, a fraction within a fraction, or multiple fractions within fractions. We are going to want to clean those up. So anytime you've got a 1 divided by a fraction, that results in just the reciprocal. So this would end up being negative 17 over 8. This would end up being negative 17 over 15. And then these two here, we would think about them as two fractions divided by each other. Now, one way to think about them if they have the same denominator is to just cancel out the denominators. And so we end up with these values. Oh, it's always a good idea when you're doing something like this to double check your signs. Remember that we use this little device in the previous section where we learned about what functions are positive in which quadrants. All of them are positive in quadrant 1. The sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3. And cosine and its reciprocal are positive in quadrant 4. So since we know that we're in quadrant 3, only the tangent and its reciprocal are positive. You see those are positive. Everything else ends up negative. And that's just a good quick double check to make sure our signs are correct. Okay, this one is a little bit different, but it's similar to the one that we just did. This time we're not given a coordinate, we're just given an angle. So we're going to use this figure to find the values of the 6 trig functions if we know that t, or our angle measure, is 3 pi over 2. So we definitely want to visualize where this point is. We know that it's going to be on the negative y-axis on the unit circle. And if we know that, we're going to go ahead and use those definitions again. But we're going to recall that from that point, our x value is 0 and our y value is negative 1. So again, we're going to go ahead and replace our x's and our y's with the corresponding values. And then we would want to simplify. Now anything with a 0 in the numerator, remember, is just going to be 0. And anything with a 0 in the denominator is just going to be undefined because we can't divide by 0. Okay, and so that's the end of part 1 of GS8. The second part, we're going to talk about how to come up with all the coordinates on our standard unit circle and then how to use them.